Welcome back, database enthusiast. Ever wondered how database keeps data organized and accurate? It all comes down to two crucial concepts. Those are data type and constraints. Today, we are diving deep into these fundamentals of SQL, and by the end of this video, you will understand exactly how they work. Let's get started. First, let's talk about data types. These are like labels that tell the database what kind of information to expect in each column. Think of it as organizing your toolbox. You wouldn't put nails in the screwdriver drawer, right? Let's see what all data types we have. We have numeric, string, datetime, binary, and enum. Let's look what all subcategories do they have. First, we have numeric, wherein we store data which consists of whole numbers. We have four subcategories in numeric data. First one being int. It stores whole numbers like age or quantity. It can store 4 bytes of data, that is 32 bits. Float, it is used for faster calculations, but float is prone to rounding errors. Avoid float for financial data. Third, decimal. It stores numbers exactly as specified, used for currency, percentages, or any data requiring precise calculations. It has two parameters, precision and scale, where precision refers to the total number of digits the data can consist of, and scale refers to the number of digits after the decimal point. Fourth, big int. Using this data type, we can store values till 64 bits, that is 8 bytes. Second, we have string. String is a sequence of characters. There are three subcategories in string data type. First, char. It always allocates the specified length, padding with spaces, used for fixed length codes like state abbreviations. Second, varchar. It stores only the actual characters plus a length byte, good for names, addresses, etc. It has a limit of 255 characters. Text, used to store large amounts of text or string data. It is typically used when the length of the string data is variable and can be quite large, such as paragraphs of text or entire documents. Third, we have datetime data type. As the name suggests, it is used to store data related to date and time. We have three subcategories to store date and time. First, date. The date data type is used to store only the date, year, month, and day without the time component. The format is YYY-MM-DD. Second, we have time. The time data type is used to store only the time without the date component. Format for time is HH MM:SS. It is useful for storing time of the day without the date, such as business hours, shift times, or event start times. Third, we have date time. The date time data type is used to store data wherein we require to store both date and time information. The format here is YYY-MM-DD space HH:MM:SS. This type of data is commonly used to store timestamps for events such as the time a record was created, when a transaction took place, or when an order was placed. Fourth, we have binary data. Binary data represents information in a format that computers understand directly, such as images, audio files, video files, documents, executable files, etc. It is essentially a sequence of bytes. There are three subcategories of binary data. First, binary. It is used to store fixed length binary strings. Second, we have var binary. It is used to store variable length binary strings. These two are commonly used for storing smaller binary data such as encrypted data or hashes. Third, blob. Blob stands for binary large objects. Blobs are designed to store large amounts of binary data. They are ideal for storing files like images, videos, and documents within a database. Lastly, we have enum. In SQL, specifically in systems like MySQL, the enum data type is handy tool for defining a column that contains only predefined set of strings. Think of enum as a menu. It gives you a limited set of choices. You can only pick from what's on the menu, just like a database column with enum. Another example we can look at is a clothing rack with hangers displaying a small t-shirt label, a medium t-shirt label, a large t-shirt label. Hence, we can buy t-shirts only from these available sizes. Choosing the right data type is essential. It optimizes storage, ensures data consistency, and prevents errors. Using an int for a name would be a recipe for disaster. Now let's move on to constraints. Constraints are rules that enforce data integrity and accuracy. They are like safety checks for your database. Here are some common constraints. First one being not null. It ensures a column cannot contain null values. Second, we have unique. It ensures all values in a column are distinct. Third, we have primary key. It uniquely identifies each row in a table. It's a combination of not null and unique. Fourth, we have foreign key. It creates a link between two tables, ensuring data consistency across related tables. Fifth, we have check. It ensures that data in the columns meet a specific condition. Lastly, we have default. It sets a default value for a column if no value is specified. Constraints are vital for maintaining data quality. They prevent invalid data from entering your database, ensuring your information is reliable. So, to summarize, data types define the kind of data you store, and constraints enforce rules on that data. Mastering these concepts is crucial for building robust and reliable databases. If you found this video helpful, please give it a thumbs up, subscribe for more SQL tutorials, and leave a comment below with any questions you have. Thanks for watching, and I'll see you in the next one.